eu vou usar o mesmo, Vou continuar o de ontem, né?
Tá bom.
Opa. Não. Bom, vamos lá, vamos começar. Well, yeah. Hello everyone. So, good afternoon. Yeah. So, did you have a chance to review a bit the notebook from yesterday, or not much time? Okay. So this is how it goes, right? So it's an intense month. Okay. So today, as I as I promised you, it will be another class of going through all the syntax of Python. Okay. So I'm pretty much following from the same notebook as the last time. Do you still have the link, or should I put it again over there? You should probably already have it if you open your collab again, but I can put the URL up again. Do you have it? Someone doesn't have the link. Everyone has it open? Yeah? It's the same as yesterday, because I am just continuing it. Yeah, yeah. So just before we continue, right? So just a few comments on what we did so far, right? So we have, this is weird. So what did we do last time, right? So we had here arithmetics, strings, Booleans, comparisons, variables, lists, and then we are only missing, there are some other objects in Python, of course, dictionaries, tuples, there are a bunch of other objects, but they are not so commonly used. So I will skip, as I said yesterday, we are not trying to have a complete set of syntax, because this takes too long, right? But we can do a lot of stuff only with what we are going to see here, okay? And then if we need something later, I can just introduce it later, okay? But, so let's get on with it, right? So I think today perhaps we have some time for working on it a bit, okay? So, so next step, right? So we stopped it here yesterday. Do you remember that? On this, okay? Next step is flux control, right? So anybody doesn't know what is an if-else, or is this a bad question? Because if someone doesn't know it, they will never. Okay, someone did raise their hands. Okay, how does an if-else work, right? The if-else work is like this. You have some condition, right? So you test if some condition is true or not, right? And then you only execute code. You only run this code here if this condition is true. Okay, and the else thing is the opposite, right? So if you have an if-else, you test something, here it is, right? So you test something, if this is true, this is executed. If it is false, then what is in the else part is executed, right? So if this is true, run this and not that. If this is false, do not run the first one, run the second one, right? So this is the basis of if-else, okay? In Python, right, you have, you always have, when you have an if-else structure, you have a block of code that is run, right? If the condition is true. How do you delimit a block? This is something that is very peculiar in Python, right? This is, there's an kind of love-hate approach here, because a lot of people hate this and a lot of people love this, okay? A block in many languages is delimited, like in C, in R, and so on, is delimited by braces, okay? This is not so in Python, okay? In Python, blocks are always delimited only through indentation, okay? Indentation is this spacing from the left side here, you see? So you have to align all of your codes to the left. You cannot just do this, right? This is wrong, okay? You cannot just do stuff misaligned. You have to align all your code to the left. And when you have a block of code, this block of code is a few spaces to the right. You see? So this is how you delimit a block. So for instance, if I have this code here, right? So Okay, let me run this, right? So this is just to show, well, but this is false, right? So, yeah, let me run this just to see. So this is what happens here. This is a false condition, okay? And then this ode is not going to run. It will print test1, true, and here it will run test2, and this print true here, you see, here it was aligned to the left, and it was outside this block, okay? It was outside this block. This print true here, the line 4, was outside the block, okay? But here, it is inside the block, you see? Because it's aligned within the block. Do you get it or not? It's, yeah? Yes or no? Is it, I think I had it larger. Does this help? Yeah? Okay, so you see that this is a line here, right? So this print true here is inside the if, so it doesn't get executed because this is false, okay? So in the test 2, you get directly to the end. You don't run print true as you had before. You see? So this is nice because all code in Python, since blocks are delimited by indentation, all code has to be indented, okay? So in C, in other languages, you can just not indent at all, or indent in very weird ways or funny ways and so on, and the code runs, right? In Python, code that is not indented doesn't even work, all right? So all code is indented, and then it's easier to read, okay? So this is the idea, and then you don't have the famous problem of forgetting to close the braces at the end of a block because there are no braces to close, okay? One thing is that you need this 2 dots here, right, after the if and else, okay? You have this if condition 2 dots here, okay? Okay. Okay, but then there are a few details about indentation, right? So you cannot indent like this, okay? If you cannot mix a different amount of spaces, right? If you have here 4 spaces and then you go to 3 spaces, this is an error. You see that it already shows it's an error that there's this red underline here. If I try to run this gives me an indentation error, okay? Because it misaligned here, you see? So I just have to add one more space here, and now it is correct. Okay? So you cannot mix the size of the spacing, okay? But you can, but something that you can, right? There's nothing in the rules itself that tells you that you have to use 4 spaces or 3 spaces or 2 spaces. It could be 8 spaces, could be any amount, right? So you can align with 4 spaces, you can align with 2 spaces, and even in the same code, each block can have a different spacing, right? Is this a good idea? Definitely not, okay? Don't do codes like this, where you have one block with 4 spaces and another with 2, right? This is bad usually. This code runs, but it's not a good idea. Actually, in Python, there's a strong convention to use 4 spaces, right? So usually what we do is that in laboratory, in other editors, if you hit tab, instead of having a tab, oh, actually this was 3 spaces, okay. It adds, instead of adding a tab, here you see, you know what a tab is, right? Yeah? Instead of adding the character that is a tab that you jump directly, right? It adds 4 spaces instead of including a tab. You see? I just, let me do this again. If I just press tab here, it adds 4 spaces, okay? Nice. So let me just, yeah, this. Something that is useful to know is that in, I think the default laboratory, there's if you go to the configurations of the editor, there's here the length of the indentation, right? So you can change this to 2 or 4. Yeah, I think the default is 2, but since all codes we are going to write is with 4 spaces, it's better to change it to 4, okay? Yeah. Okay. So Oh, this is wrong here. Attention, son. Yeah. So another nice thing is that suppose that I want to change the indentation of a whole block, because this is simple, right? This is a single line. I can just am here, and I have this, right? So suppose I had this out like this. I want to put these two print statements inside this block. How do I do that? Do I have to go if I have a long list of a long code block? Okay. What I can do is I can just select this two and hit tab, and then all of it goes to the right. You see? So you don't have to. You can just select the code and put it all inside of the block. Okay. If I hit another tab, it goes another 4 spaces, another 5 spaces. If I want to go back 4 spaces, there's Shift tab. Shift tab goes back 4 spaces. So I can easily change whole code blocks to the left or to the right. It depends on where I want it to be indented. Okay. Questions? So this is a fundamental aspect of Python that is very different from other languages, right? It takes a while to get used to it because it's only spaces. There are no, you cannot just indent or code whatever you want. But this is yeah. One thing that you have to be careful also is that sometimes empty lines can be tricky, right? I think this, yeah. I think this works. Because you have 4 spaces here, I don't remember if this works. Yeah, this works. Yeah, empty lines don't count towards the block, right? Yeah. Okay. Now we have a few more examples here with if and yeah. Questions?
Why is this print end at the end?
Because there's a print end here. Outside of the block. You see?
Yeah, why? Why is it there?
Sorry?
What are you using this for? Print end.
Oh, why did I put this here?
Yeah.
Just to see that the code ran without printing any of these 2 blocks.
Okay, thank you.
Yeah? Yeah. Yeah.
So whenever you have an indentation, you have to have something coming before it to specify the indentation. Because, for example, I tried here, when you mix indentation lengths. So if you have print, if 1 is higher than 2, then print false and print true. But if I just remove, instead of the print true line, I put
yeah, if you do
spaces.
this like this, right? So you have something like this.
The
Print
example.
this, but already started like this. Is that the question? Without the...
No, like, for example, in the above cell, yes, that one.
Yeah.
Like, it'll print the false, right?
Yeah, well, this is wrong, right? Let me just add this space here.
Yes.
Yeah,
no.
like this. No?
But
sorry.
Yes, but I want to talk about like the wrong example.
Yeah.
So this code will print false, right?
This code doesn't run, right? Because it's misaligned. It doesn't even run because it's misaligned. So if I try to run this is an indentation error.
Okay.
Okay, so this is just wrong syntax. The code doesn't run.
So yeah, I can't word my question correctly, but it's like, why does it not recognize there are 3 levels of indentation, you know?
I see, but I see. The thing is, you cannot just, so this is what I was doing here, okay? If you run this, right, it's okay, right? But if I run this, I cannot just start a block anywhere. I cannot do this. Something like this. This is an error too. Because you don't start a block from nowhere. To start a block, you have to have something to define that block, right?
Yes,
so you need
exactly.
an if, an else, a function definition. You need something before that, right? So yeah. So you cannot just I decided I printed 2 and now I decided that this is a new block. No, right? As with braces, right? It's different. Yeah, in R you can start braces from nowhere, but not in Python. Yeah.
No,
That's
but
the-
that was
yeah.
exactly what I was asking. So
Okay.
if I want to like add that third level of indentation, I have to add another function. For example, an if inside an if.
Yeah, exactly.
Okay.
Yeah. Yeah. Right. So one thing for is that I think if you start, if everyone is aligned, I think this works. No, it doesn't, right? No, it doesn't. Ah, yeah, it works. So it's always relative to the first line, right? So if you started with 4 spaces, it expects to keep 4 spaces until you have some keywords like if, else, a function, or something else to, you know, to that requires a block. You know that? Yeah. More questions? Okay. So let's go. Move on. So this is an example with if else, right? So you have here a check. I'm checking if this variable here is greater than 10, lesser than 10, or equal to 10, right? Or actually, I don't test if it is equal to 10. I just end off, well, it's either either higher, lower, or equal, right? So this is the if-else structure, right? But then there's this elif here, right? What is elif? Elif is just else if, when you want to test if the first condition is false and you want to test a new thing, you see? So this is equivalent to else if, actually, right? So this work, but it doesn't like else if, right? Because else expects a block, and if also expects a block, but if by itself is not a block. So you have to use elif for this structure, right? So this is why elif exists. Else expects a block, but you cannot start a block with a statement if, right? So you have this elif. This is meaning else if in most other languages like R, C, and so on use else if. Python uses elif. Okay. Is it clear what this does? Right, so I test if the variable is larger than 10, print this, and if this is false, then this gets run, right? So if I, for instance, if I have, if I put 15 here, okay, like this, all of this stuff here is never run, okay? It doesn't get here, okay? It stops here. It prints this and ends directly, okay? It doesn't even go through the elif and else. So this is elif is different from a simple if. Okay, if I test it, if I put this here, okay, it doesn't go here because this is already true. You see? So even for this condition here is true, you see this condition here is true, okay? But it doesn't print this thing because it doesn't get here, because it only gets here if this one was false. Okay? Yeah, yeah. Okay, so let me, okay. Good. And of course, this is the same thing with else, right? Else will only come here if this is false, and then this is also false, and then it gets here. Okay? Yeah.
So the elif works just as a second condition. You could add more ifs for an else?
Yeah, yeah, you do a lot of other elifs here. Yeah. You can do as many elifs as you want, right? You can do another elif here. I don't know. Oof. Yeah, something like this. You can do as many elifs as you want, right? So you can do only a single if in a chain, right? And finish with an else, right? But you can have as many elif conditions in the middle as you want, right? So this works. Right? Of course, if I put 10 here, it doesn't get to the last one, right? It gets here, and it doesn't get in the else here. Yeah? Okay? Okay, so this is conditionals. It's only this stuff here. So anything, there's another detail here that whenever you have an if, an elif, or an elif condition, this thing here is treated as a Boolean, right? So remember that we talked about Booleans up there, right? So of course comparisons always return true or false, okay? But if you have something, let me do something else here, right? So I have a string here that is empty. If s, I can do this, right? This looks strange, right? But this is just meaning that you see. Remember that if you put just a single variable or something else like here, like in the condition that is not a comparison, it's not something that is already Boolean, it will be converted to Boolean and then tested for true or false. And then integers only 0 are false, in strings only empty strings are false, and so on, right? So this is sometimes useful to test if a string is empty, right? Of course, it can also use if length of the string is equal to 0, this, right? You can also do in the more lengthy way, but this is also possible, okay? So, so you don't have to worry, you can put here anything that it will be converted to a Boolean. It's usually better to use comparisons because it's easier to understand what it's doing, right? Yes? Is it on?
Is it possible? The example of
I can hear you. Can you speak a bit louder? It's working, but you have to be closer or be louder.
Okay.
Yeah,
can you
you
go back to the example of, yeah, that one. Can you, is it possible to make an empty variable? Like if the variable is null, something like that?
Ah, okay. If you want to check if a variable is defined, is that the question?
No, it's like if I want to check if the variable is null.
Ah, okay. In Python, because I think in terms of error, right? Error there's this null, okay? In Python we don't have this null exactly. We have something that is called none, right? So it's written like this, none, okay? And none is kind of a special thing in Python. You just ask if s, well, this will none converts to Boolean as false, okay? So this is not wrong, right? And just do this. But of course, this is going to be false if s is known, but also if it is 0, and also if it is an empty string, or also if it is false. If you want to check if the variable is none, you can ask if s is known. You see? And then it only returns true, or if s is known. Now, of course, if you want to deny this, you put a not in the front, right? In front of it. If not s is known, okay? This is how you change the, yeah? Okay? Okay. More questions? Yeah? But I just want to point out that none is a lot less useful in Python than it is in R, right? So it is a lot less common. I think the most common thing that you're going to see none is when you, we will talk about this in a moment, is when you forget to return stuff from functions, right? And then it returns none. Usually it's a kind of forgetting stuff, yeah.
But even when we're dealing with data tables, data frames, it's still not useful?
No, usually not. Usually not, yeah. We will not deal much with data tables from, we're not going to import data, we are usually generating our own data, right? And usually when you generate your own data, you don't get empty values, right? You can have stuff like, you know, not a number, and then this is a none, not a known. Okay, we thought, you know, in floating points, like if I, let me give you an example here. I think if I do this, this is just a yeah, a division error, I think you have to do something like, to get a none, I think you have to, maybe, yeah, no, it doesn't let me do this, right? How do I get a none? I think I have just, yeah, this is, yeah, I think I have to use, yeah, it will come up later when we introduce Numpy, okay, when we actually do more calculations, right? But the difference is that a none is not the same thing as a none. A none is more or less common to get, unfortunately, but you don't usually represent missing data. You represent missing data in different ways than in R, you see? Not with nones, okay? Okay. So this is, essentially this is why nu is so common in R and not so common in Python, okay? Because none doesn't mean missing data, it means something much more specific, okay? Okay. So, moving on, yeah? So, well, now that we have seen conditionals, we can have loops, right? What is a loop, okay? A loop is when you iterate over either a sequence, when you iterate over a sequence, when you do exactly the same operation, same code block, but for different elements in a sequence, right? So this is the basic structure. You have for variable. So this is you give, this is pretty much anything, but you have to give the name of a variable here in. So this is for variable in, and here you have a list. Okay, a list or any sequence actually, right? So it can be a list. It can be it could be an array later. It could be there are other stuff that can work as a sequence, okay? So we can have a range of integers and so on, right? And then you have a code block that uses, usually you use this variable here, right? So here you just print this stuff here, okay? So the basic stuff is pretty simple, okay? Yeah. Try to yeah, but try to do, yeah, okay.
That variable could be named anything, right?
Yeah, exactly. Anything that is a valid name, of course, yeah.
Okay, so like the script just identifies that everything that's inside the commas are variables. So
well, actually, this is a list. Okay, you remember that we talked about this. Okay, so this is a list with 3 elements, and then in the first pass here, animal has the value dog. In the second iteration, it has the value cat. In the third iteration, it has the value rabbit.
Yes. Yeah. Oh, no, yeah, it's just a bit confusing to me because I'm more familiar with R, so it feels like I have to inform it before what is animal, you know, but it just grabs the first element from the list and runs the code, and then the second, and then the third, right?
Yeah, I think this is exactly the same as in R, right?
Yes, it
R
is.
does in this way, yeah.
But I'm confused in R too.
Okay. Sure. But is it clear what this is doing?
Yes.
Yeah? Okay. Questions in the back? I can hear you again, sorry.
What is that?
Okay, we talked about this yesterday, right? So you have, this is how do you do string formatting. Do you remember? Let's go back to strings quickly. So here we had strings, this is a string, and then there's this funny thing that you can do with a string, that you can put an F here, a format, before the delimiter, and then anything that goes inside a brace here is the name of a variable or some small piece of code here, you see? So it puts name here. Let's run this. So you see, you print welcome to the, and you substitute this with the variable name that is quantitative ecology. You see, welcome to the quantitative ecology course. Okay, so this is something that we saw yesterday. Okay. Yeah. So let me go back to the 4. Here. Is okay? Just that? Oh, okay. Okay. Okay, so this is a simplest example of a for loop, okay? Then an instruction that is really useful, really common, is that you have to iterate, as you'll see it's common also in R in other languages, is that you have to iterate over a range of integers, okay? You want to run for an index from 0 to 10 or something like this, right? So for that, you have this function called range, okay? And range gives you a range of integers, right? Pretty much the same as the notation in R that is, I don't know, 0 to points 10. You go 0, 1, 2, up to 10, right? So this is what range does, right? This function range. Yes? You had a question? Yeah.
In this section you are now, in the beginning, used iteratively in lists and vectors.
Sorry, I don't get it.
Beforehand. Yes.
Yeah.
No.
Yeah. Up or down? Down. Oh, you're already down here. It's up in there. It's up there.
Isso, é.
Yeah, okay.
I use R and I know that vectors are different from lists, but I do not understand the difference here because I do not remember you saying if there were any differences between lists and vectors.
Yeah, the main difference between lists and vectors, we're going to talk about vectors this year, right? So don't worry, we will go into detail about vectors, but the main difference is a list can contain anything, remember that? Can contain anything, can contain another list, can contain integers, can contain strings, and mix all of them together. So a list is kind of anything, right? A vector is usually reserved to all elements of a vector have the same type. It's pretty much like a vector in R, right? All of them have to be the same type, or either they are float, or integer, a string, something like that, right? So they are much more constrained in that sense. And you can have multidimensional vectors also, right? So just as you have matrices in R, right? You have two-dimensional vectors that are matrices, three-dimensional vectors, and then you have multiple indices, okay? Instead of having to do lists of lists. Okay.
So there, in the code you are running, animal is a vector.
Well, actually, animal is a variable that will receive a string. Okay. So you have a list here. So let me do this, right? So this is our list here. So let me do. Where's the? So I'll tell this stuff here. This is our list, right? So this is just a list, okay? Just as we did yesterday, right? So I can print this list. You see, there's nothing weird about it, and then we can just iterate over this list, for instance, right? Like this. So Li here is a list, okay? And iterate over the list, taking each value of the list one at a time. Okay, of course, you can see that dog is a string. A string is also a list of, of characters, right? So it can also, for instance, I can do for C in dog, for instance. You can do this, right? You have the 2 dots here. Okay, never forget to have these 2 dots before starting the block. For C in dog, print C. This will print what? Since a string is a list of characters, this C receives each character of dog, G-O-G, okay? So in a sense, this is kind of a list of lists, except that this is actually a string, right? It's a list of characters, okay? Yeah.
Um, so in an example similar to that one of the dog, if I have a word that has, I don't know, uh, that has like repeating letters, you know, a word that, for example, animal. Yes, yes. If I want to like use a for to print only the D's inside of dog.
Ah, well, this is what we're going to include an if inside the for. This is what you're saying.
Yes.
We are going to see this in a moment. Yeah.
Okay.
Okay? Yes.
Good afternoon. I was thinking if you can give us some example of how do we use stuffs like this in real life.
Well, we will see this in a moment also. Once I want to finish going through all of the syntax before taking on some examples for us to work on this, right? So, of course, it's real life here is like toy problems, but still, yeah.
Okay then.
Can we wait for that?
Okay.
Yeah, sure. Please.
Just to be sure, you put the letter C when asking for each letters of the word dog.
Yeah.
Could you have put any other letter there?
Yeah.
And Python would have recognized it as a letter?
Yeah. Like this.
Oh, that's cute.
Yeah, it's okay.
Okay.
Yeah. Something that you just have to be careful is something like this. So if you have something like, well, I had that A was 10 over here, and I do this, and I print A at the end, after the for, you see, outside of the for. You see, it's not 10 anymore, right? So if you use this letter for something that was already a variable name, of course, this gets destroyed.
Oh, I
Of
see.
course, yeah.
And in this case, for animal in list,
Yeah.
the Python already knows what an animal is, or did you assign that for
Yeah,
something?
I'm assigning that. Yeah.
You assign
Yeah.
it.
So in each step, I'm assigning the first element of the list to animal, then the second element of the list to animal, then the third,
Oh, okay.
one by one. You see?
Was
So you don't have to have animal defined beforehand.
Oh, you don't need to.
You don't need to, right? Yeah, since everyone was kind of familiar with R and Python, I didn't talk about types and declarations, right? If you are familiar with C, this can be a bit weird that you don't need to declare any variables at all, right? Like just as in R, okay?
No, it's
Never
just that
declare variables. Yeah.
it's because in my mind, since I usually use R, you even need to define animal for the R to recognize as anything as an animal. Like what is an animal?
I think you don't have to declare beforehand in R what the variable before using it in the for loop in R either. You don't.
I'm learning new things today then.
Yeah, you don't, right? And you can write in R pretty much the same as this stuff here. So in R, of course, this will not run here, right? So I don't know if this computer has R installed here. So let's go through intercourse here, content.
Thank you.
Right, so this is, yeah, like for x in 1 to 10. I think in R I need a parenthesis here, I think. I can do this print x, right? I think this works. Oops, how do I, yeah. I didn't define, the font is too small here. How do I? Yeah, you see what I did here? So it's pretty much the same structure. I have here, I need this parenthesis here that R uses for the for. And here it is the same as the range, right? And then you have a block code that you don't need to indent, you just put braces and that's it. Yeah.
I think we have to create a variable before in R when we want to save the results after the
Oh
for.
yeah, of course. If you want to save the results, then yeah. But you don't need it just to iterate over, yeah. You see? I think that's, yeah, okay. Is it clear now? Okay, let's go back to Python. Okay, so what else we can do with a for, right? So this is, of course, you have a list. We also see that you can treat a string as if it were a list of characters. But the most common use is when you want to iterate over ranges of integers, right? So pretty much like in this example here, you have this 1 to 10 integers, okay? In Python, you have this function range that goes, and this is pretty similar to the slices we were discussing before, right? It starts with 0 and goes up to 4, but doesn't include 4 itself, right? So range 4 will give you 4 elements, starting at 0, so it goes up to 3, okay? So the loop 1 here is 0, 1, 2, 3, okay? So I just printed I here. For I in range 4, it goes 0, 1, 2, 3, okay? If you want to start in something other than 0, then you have to give two different values here, the start and the end, okay? So it starts at 4 and goes up to 8, not including 8 again. So pretty much also again, like in the slices, okay? It starts at 4 and stops at 7, okay? And also if you want to go in steps of 2, instead of going 4 up to 8, you want to go in steps of 2, right? So you just put a further argument to the range, and start at 4, stop at 8, steps of 2, okay? And then you go 4, 6, let me put some more here, right? So let's go to 12 here. Yeah. 4, 6, 8, 10, okay? Yeah, clear? And of course, you can also do something that we did with the slides, that you can go in the backwards direction, okay? You can also have negative indexes here, okay? If I put a negative index here, what happens is that you have nothing, okay? Because if you start with 4, it tries to go backward, and this is all, this is not going towards 12, right? So, so you have to actually invert here, you go from 12 to 4 in order to get this negative stepping, okay? And you see that it doesn't go to 4, like stop before, okay? So, clear or? Of course, sometimes it can be a bit confusing, but you can always play a bit with your code to check that it does what you expect it to do, okay? It's something that is possible, okay? Okay, so let me go back to how it was before. Now, for your question, okay? Another way to do loops is, it's very common for you to want to do something in a loop depending on the variable, of course, and then do ifs inside the loop, okay? And the most common thing to do is you want to stop the loop in the middle, okay? What if you want to stop the loop in the middle? You are, for instance, searching for something inside the list, and once you find it, you stop. And you don't want to continue with the loop. So for this, there is this keyword called break, okay? Break stops the loop. Once it hits break, it stops the loop and gets out of the loop, okay? So let me run this. What does this do? It goes from 0 to 4, not including 4. But when it hits 2, when I equals 2, it breaks, okay? It stops, okay? And you see that, will it print 2 or not? Oops, already seen the answer, right? But yeah, you see that the print here is inside the for block, but after the break, okay? After the break. So it doesn't print 2. It prints only up to 1, you see? Because once this is true, it breaks, it doesn't execute this print here. If I want to print up to 2, including 2, then I have to put this print before this if condition here, okay? And of course, it doesn't execute the following, the following stuff, the tree here, okay? Yeah, clear? Okay, and another keyword that is important here. So you see, this is you see the indentation here, right? So we have the first alignment here, then we have this block here, the for block is this whole stuff here, and inside the for block we have another condition, and you have a third indentation here because break is inside the if, you see? If you want to print only when I hit 2, then you can put this print inside this thing. Of course, I have to do the break after the print, okay? Let me do this here. Now you only print 2 and then you break after you hit 2, okay? You see? Okay, so let me go back. Okay. And another thing that you can do is sometimes, of course here maybe, suppose that you want to print all of the numbers except for 2, okay? So you want to do something different with 2, right? When I equals to 2, but you don't want to break the loop at that point, okay? You just want it to skip the rest of the block, okay? So not print it, okay? Then you have this word called continue. Continue is what it says. It tells you keep running the loop. But this keep running the loop means keep running the loop, skipping the rest of the block. So it will skip this print here, right? So if I run this, you have 0, 1, but not 2, right? Because once you hit 2, it hits the continue that goes back to the beginning of the old block with the next value, that is 3, without printing, okay? Yes? Easy. So this is it about fors, okay? For loops. Clear? Okay, let's move on. So the next instruction that is still a loop is the while loop, okay? So while is used to run code whenever a condition is true, okay? So you have while some condition, and then you have an old block, right? So this structure is pretty much the same. You have while condition, two dots here, and then you have the old block. So for instance, I start at 0, I do while x is smaller than 4, I print x, and now this is an assignment. I just put this here. You would write x equal to x plus 1. There is this shortcut that is x plus 0. You change the, this is pretty much the same. By the way, this is exactly the same as writing this, right? X equal x plus 1, okay? I think C also has this instruction, okay? But yeah, x plus equal 1 means x equal x plus 1, okay? You are just summing 1 to x, okay? So I start with 0, it will print 0 in the first iteration, add 1 to x, then 1 is smaller than 4, it will add 1 again, then add 1 again, until it reaches 4, and then this condition will be false, and then it will stop, okay? So we have 0, 1, 2, 3, and when this becomes 4, it goes here, and it doesn't execute the block, so it doesn't print 4, okay? Yes?
I understood what's happening here. But also, if the x plus equal 1 is just a shortcut for x equals x plus 1, why doesn't it overwrite the x equals 0? You know?
Can you repeat it? Sorry. I have to do this because if x is not defined, so suppose that I delete x here, okay? Del x. You don't have a variable x.
Yes.
It has no value. How do you say the variable? Because when I write, even if I try to write this, right? This doesn't make sense because you cannot evaluate the right hand side. Okay?
No. Yes.
So you need to have x defined beforehand.
Yes. But I guess what's making me confused is just that you're using x before and after the equal, you know? Because it was x equals 0, and then you also said x equals x plus 1. So I understood that x should start at 0, and then it'll add 1 plus 1 plus 1 plus 1 plus 1. But why, like, for example, there was somewhere before, I don't know what cell it was, but it was related to the a variable, and then a was equal something, and then you added a equals something else, and then it overrides.
I see. So this is, I think, one of the main differences between the for and the while, right? The for you don't need to have the variable that you are iterating over defined beforehand, right? It will always assume the values in the list that you use it to go for, right? In the while condition, the condition for the while must be defined beforehand. You see? So, of course, at the end of all of the stuff, right, if I go here after, okay, if I print x here, it should have value 4, okay? Yeah? Because I printed outside. And let me do something just to be very clear about this. Outside. Yeah. So you see, I need to have this beforehand, because if I don't have x defined, once even before starting this code here, I have to be able to compare x to 4, right? And then inside the loop, I need to change x until this condition is no longer true. Okay, so I need to have this defined, but of course the loop is going to change also the value of the variable. Yeah?
Yes, I understood. Yes, it's okay.
Yeah, okay, okay. Yeah? Question?
I'm sorry, I wanted to go back to the loops for example, the second example.
Yeah? This one?
The second.
This one?
Yeah. I just didn't want you.
Okay, what is this stuff here? So, remember that I said that it iterates over anything that is a sequence, right? So, a range is a special kind of sequence, okay? If I try to, this is actually a kind of object, right? Let me run this again. So if I say, for instance, I would call that this is range 4, okay? What is R exactly? So let me try to print, this is the question. What is the range exactly?
No, it's not that. Because I remember. But I was using the range to iterate over.
I can hear you very well. Sorry.
It's just if I want to like iterate over the indexes of a list or something like that.
Yeah.
Would I use range too?
Yeah, exactly. So for instance, if I want to go back to this example here, right? And instead of calling animal, right, in li, I can also say, well, I will go over an index where I have the range. That is, this is a very more convoluted way of doing this, right? But instead of doing this, I have to, you see what I'm doing here? So to go over the indexes of a list, I have to go over all of the integers from 0 up to the length of the list minus 1. That is exactly what range len of li does, right? So this is what you use, right? You have range len of li, where I now is the index, okay? So you not use animal here anymore. Animal is not defined anymore, right? Now I have to use the list with an index, okay? And then this is li I. You see? And it works, again, in exactly the same way, you see? So you have now I going through 0, 1, and 2, and now I have li index 0, li index 1, li index 2. Is that the question? Can hear you.
La la la. Is it working? It is. Okay. The question was, I've done that before, like using range to iterate over indexes of a list, but now I'm looking at it and I don't know why I've used it. Like, is it ever useful to
Yeah,
write
both
it
for-
like
yeah.
that, or
Yeah.
or it's always like more useful to just say for I in list.
I see both forms are useful. Okay, depends a bit on the context. Okay, so this form here, so you have a list, and you take and you iterate over the indexes of the list, and mess with the variables and so on, right? Right. This is useful sometimes, and sometimes it's useful to just iterate over the list like before, right? So this is also useful. Depends a bit on context. Okay, both forms are useful. Yeah, I don't know. It's not like always one or always the other. You see, so there will be different uses for them. Okay, so especially if you want, for instance, suppose that you want to so I think it's pretty simple to recognize that this form looks much more nicer than the other one, right? When you just have a single variable receiving the value of each animal, right? This looks nicer, right? But what if I wanted to change the list? Suppose that I want to say, well, now I will make the plurals, okay? And then how do you make the plurals? Oh, I take the animal and I add an s. So something like this. I just add an s to the end, like this, right? Well, I can print this, okay? Dogs, cats, and rabbits, okay? But what if I want to make the list itself change? You see the li, the content of li, right? If I just say animal now, if I do this, animal equals animal plus s, right? This. Well, it will print with an s now, right? Because animal was dog, then it became dogs, and then I printed. But if after this I print the original list didn't change. You see? So in this situation, I need access to the list itself. And when you need access, you need to change the list itself. Then what you need? You need to change the list. So I need to go over the elements. So you need to do for I in range len li. And now I say li I is equal to li I plus s. And now I'm changing the list itself, okay? Now I have to do also li I over here. So you see that now, not only I'm printing, right, but also I'm changing the list itself, right? So if I need to change the original list inside the loop, then I need to iterate over its index. Okay, if I don't need to change the list, then the other form is more comfortable. Okay, so this is maybe one pretty big difference between the two. Okay, good question. Yeah, more question? No? Okay, so back to while loops. Yeah. So you see, even though syntax is simple, relatively simple, it takes practice, it takes you to work on real examples or trying to build code to start identifying when something is better than something else, you see? So, and this comes with practice, okay? It's nice that we have questions that we are already identifying a few of these things, but more comes with time, okay? Okay, so while loops, we had this already, okay? Here, an attention here is that you can have infinite loops, okay? So a for loop, since a for loop is kind of always, you already have the list over here, okay? It's pretty hard to make a for loop, since it doesn't take a condition, it only takes a list. You cannot really build you can with some trick, right? But it's really hard to build an infinite list, okay? To have so it's really hard to get an infinite loop and a never-ending loop with for. But with while, it's pretty simple, okay? But there are conditions that is always true, okay? So this is, right? So you don't want an infinite loop because then the ode runs forever, okay? So if you have, for instance, let me delete this one here. If you have a ode like this, okay? You start with 0 and then you ask when x plus 1 is greater than x, okay? Well, it should be always, right? Pretty much, yeah? So we keep increasing x, increasing x, increasing x. Of course, it's not really infinite because at some point the storage of integers is finite, okay? And then at some point this will break down, but this will take such a long time that we can wait here forever, right? So if you see, and then this is something that we have to learn, that you have this stop button here, okay? You can just click this and it stops running, okay? So if your code is taking too long, you can always stop so that it doesn't. So this is an important point about Collab, right? It's free, it runs odes for you, but it's not infinite, okay? So it has a limit on the amount of computing you can do. This amount is not small, right? But if I leave this running for several minutes, it will stop at some point and doesn't allow me to run any more code during a few hours, okay? So don't do this, otherwise you will unable to keep using Collab, okay? Yeah? So it has some limits, right? Of course, if you're running your own computer, it doesn't have any limits. As long as the computer is running, it keeps running. But in Collab, you do have limits on computation time, okay? It's not small. It's not probable that we're going to reach this limit, but it can happen, okay? It can happen, okay? Okay, so yeah, be careful. So this is something that should be careful. If you have this button to execute everything in a notebook, right? So this is why you should, here I did something that is objectively wrong, that I just left an infinite loop in the middle of the code, just sitting here, right? If I just try to execute everything and just wait and see, it will stop here and never finish this, okay? So this is dangerous, okay? Of course, I don't have this problem here because there are errors in the code above, right, on purpose, so that the code doesn't reach here if you try to execute everything, right? When you execute everything, it stops at the first error, okay? So it doesn't really get down here, okay? But in general, try to avoid this, okay? This is to not be logged out of a lab, okay? Okay, and I won't give you any example here, but break and continue also working while loops, okay? Actually, one of the most common ways to use while loops is just putting some while here and doing if something is true, then you break, okay? It's also possible, okay? So it's pretty much the same as with the for loop. Break stops the loop and gets out. Continue stops running the block and goes back to the beginning of the old block. Okay? Simple? Questions? Okay. Well, we're finally reaching function definitions. Okay? So this, of course, is very common. So a function will also be a block of code that is always defined like this. You have this def keyword in the beginning, then you have the function name, then you have parentheses, you have a list of argument names, okay? Close the parentheses, 2 dots, and then a block code, okay? And also something that you need to know is that at the end, if you want to return some value, some variable from your function, you have this return keyword in the end, okay? So let's do some examples, okay? So suppose that we do an add function, very simple, okay? Add function, I have 2 variables, 2 arguments, so variables that are passed to a function are usually called arguments, okay? And 2 arguments, x and y, and I'm just going to say it prints x is, you see, this is a formatting thing here, x will be substituted by the value of variable x, and y is the value of the variable y, and in return, you return x plus y, the sum, okay? And when you do this, it prints, okay? But and also, you see that x is 5 and y is 16, and add the returned value is 11, okay? And this is what gets printed. You see? It doesn't print the sum inside. It returns the sum, and then since I add print here, it will print the sum, okay? Simple or not so much? Yeah? This is simple, right? Of course, and also the funny stuff, since plus is used for stuff that is not only integers, and also do this, right? And sum A with B. There's nothing wrong with this, right? This also works, right? Because yeah, I'm just saying that I'm summing this stuff, okay? So if I just pass a list with another list here, well, this is wrong, right? Just a minute. You see, I'm summing two lists, and it just concatenates the lists together, right? So this is a bit different from other languages that you don't require the arguments to be pre-specified types in general, right? So you have this add function, but it actually can receive numbers, strings, lists, and receive any kind of object, okay? And it's common practice not to go around checking the types, right? Because it's very common in Python to reuse stuff with slightly different types of objects, right? So you don't want to go around and check if an object, for instance, is a vector, or is a number, or is something else, because sometimes you can change the type of the object, but have it behaving more or less the same way, right? So it's not usual to check types, okay? I don't know if this doesn't make a lot of sense to you. Doesn't matter, right? I'm just comparing to other languages that you may know, okay? Okay. Questions so far? Okay, so let's go let me go back here just to the original. One nice thing that I think R also has this stuff, right? But is that you can usually the most common thing is that you have a list of arguments, and then you call the function with the complete list of arguments over here, okay? But then it goes in order, right? So 5 is the first argument, 6 is the second argument. So x is 5, y is 6, right? X is 5 and y is 6, okay? In the order, okay? If you want to call things in different orders, you can, right? How do you do that? You just call them calling by name, okay? So you can do y equals 6, x equals 5, or in any order you like, right? And this works, right? So here I put y first, but I called y equals 6. So now y is equal to 6, and x is equal to 5, even though I did it in the different order, okay? So you can put arguments in any order you like, if you name the arguments that you are calling, okay? So now a question, right? How do you know what are the names of the arguments with a function, with a given function? Of course, here I just define an add, right? So we know from this that the names of the arguments are x and y. But if I'm writing code, for instance, let's see, we just used range, right? Range. I had 3 arguments, right? The start, the finish, and the stack, okay? What if I wanted to change the order? If I want to change the order, I need the names of the arguments, okay? You do this looking at the help, okay? But one nice thing about the lab is that once you write the name of the function, it will show you, but range here. Range start, stop, step. Okay, so these three here are the names of the arguments. You see? So if you just write the name of the function, usually it pops up a help box telling you what are the arguments and what are their names. Okay? Here there's already something interesting that most functions sometimes have optional arguments. Okay? So for instance, we didn't have to. If you have a single argument, it is stop. If you have two arguments, it's start, stop. And you can have an optional third argument that is a step. So you can have optional arguments. You can play a bit. These functions are written in a more sophisticated way than we're studying here, right? But you can change the argument list a bit, right? But in general, what you want to know when calling a function, what you want to know is the argument names, and you do this by just typing it and waiting for the pop-up box, okay? So this is another way to do this, right, is writing help and the name of the function, right? And then you have something that is not as helpful as I thought. Yeah, here it is, right? So, but the thing is, range is actually a class, not a function. And when you are calling a range, you are building a new object from a class. So this looks a bit funny, but here it is, right? Range, stop, start, stop, step. Okay. You see, so also help and the object you want to help is how you get more help. Okay. More details about the function or the object and so on. Okay, so this is how you discover the names of the arguments. Okay, so this is okay. So going back to function definition, you can also suppose now that I want to call a first argument, I can do something like this. I have now adding three numbers together or three variables together, right? And I can call the first one without calling the name, and the following ones using the name. So if I start with 2 here, then x is 2. But now I'm calling by name, z is 4, y is 6. Okay, so you see, z is 4, y is 6. I changed the order of y and z here, but I can do this because I called by name. Okay, something that I cannot do here is that I cannot put this before the 2. Okay, if I start with this here, this is an error. Okay, I cannot say z is 4 and then I have something without names. Once you start naming the variables, naming the arguments, all of the following arguments have to be named as well, right? You will not try to guess which one is the first one missing. It doesn't do that. Okay, so once you start naming, all of the following arguments have to be named. Okay, so this is an error. This is just syntax error. Okay, no name, no special name for this error. Okay, so this is it, right? Okay, so this is how you call a function, how you define a function, and one thing that happens is that if you finish a function, and this is pretty common, right? So a common error is, for instance, you print something here. So you print the sum, for instance. Let me do this with the first example, right? So I think it's no, it's okay here. So you print the sum here, for instance, but then you don't return it. Okay, you don't return it. You forget to return the value, okay? When you do this, what is going to be printed at the end over here? None. You see how none appears? None is what happens when you have a function that doesn't return anything, right? So I'm adding here the three numbers. You see x plus y plus z is indeed 12 as you printed here, but I didn't return this value. So when it comes here, I have this add 3, and the result of this function, the return value is none, okay? And then what gets printed here is none. So it's important remember to return the value, okay? You return value and then this is, or sometimes you don't, if you don't want to return anything, you can just return. If you type return, you just finish the function without returning anything, okay? Yeah, this is also possible, okay? So this is, so whenever you see a none coming out of nowhere, the first thing you have to look for is functions that do not return anything, right? So it's a very common error, okay? Okay, so now for something, questions so far? Yeah.
It didn't make a lot of sense to me.
Well,
could you return to the first example of
here?
of the function?
Yeah.
I think I didn't understand what exactly is happening and what return does. So let me rephrase the question. Is add an already existing function?
No, I just defined it.
Okay.
Yeah. And now let's see, for instance, I have another, the result is add.
So when you say add, you're just saying like these are the arguments that are going to be inside my function, and then return is what the function actually does.
Yeah, return, it can do stuff that it doesn't return, all right? It does this stuff, it just is not used for anything, all right? You see? Return is what the function gives back when the function finishes, right?
Yes.
So when I write this stuff here, result here is equal to the result what add1 should does, okay?
Mm-hmm.
So the return value of add is assigned to res.
Okay.
You see?
Yes, yes. Okay, now it makes more sense.
Okay.
Yes.
I think maybe this in this way here it gets clearer, okay? Yeah. Okay, so now something a little bit more delicate, more subtle, okay? That is something called scope, okay? If you don't have much experience with programming, then this will be a bit tricky, okay? But bear with me, okay? So what happens? Here, you see that with this edge function, right? We have x and y, right? You see, there was no x and y before calling the function. When I call the function with add 1, 2, it means that inside this block, so this is related to your question, inside this block here, the block of the function, x is assigned 1, y is assigned 2, right? If I try to, I think we had used x and y before, right? So let me start deleting this del x, y, okay? Oops. Well, y wasn't defined, okay. Oh, now x is not defined either, okay. Yeah, so this is it, right? So if I try to print x and y, if I try to print x here, there's no x, okay? X and y were defined only inside the block, okay? So this is something nice about functions, that you can use a lot of variables and it is encapsulated inside the function. So whatever is outside the function doesn't see those variables. So in this scope here, this scope outside of the function, x doesn't exist, it's not defined. It's only defined inside the function, okay? And it's defined at the moment that you call the function. When you call the function, x is assigned to 1, y is defined to 2, only in the scope inside the function, okay? Only in the environment inside the function, not outside the function, okay? So this is the most common way, the most useful way to use variables that are inside functions. But then can functions use variables from outside the function that is not in the list of arguments. You see, so for instance, suppose that, so this is the first example here. Let me go forward. Here. So I have x defined here, okay, x equal to 5, okay? And now, okay, this is, let me go one by one, right? So let me comment these ones here. Yeah, this will give you some trouble. So let me do this, right? So what happens if I run this stuff here? So x equal 5, and now I have a function that receives a variable called y, not x, y, but it uses x inside, okay? You see, x is not an argument of the function, okay? So which x is going to be used here? The x from outside the function, okay? Even for it's not in the argument list, at the moment the function was defined, x had the value 5. So this is the value that is going to be used for x. You see? So when I run this code, so let me use this one here. So this is the don't change x function here. Okay. So it just prints 5, okay? If later on I come here, I say x equal 10, and now I call the same function again, okay? What is it going to do? Well, here it changed, okay? So you see, it's getting, this is something that is specific to the notebook, I think. Let me, this is a kind of difference. Yeah. So you see, x is getting taken from outside the scope of the function. You see? Yeah. So it's so you can do this. Yes. Is it a good practice? No. Okay. So you can do this, but in general, the best way to work with functions is that anything that is used inside a function is passed to the function via arguments. Okay. Why is that? Because once you change the environment later, right? You don't know exactly. You may not remember what you used inside the function, right? Did I use x or not inside the function? I don't know, right? If I change x for something, for some other purpose later, I'm changing my function, okay? So this is bad, okay? Because I'm changing my function without even realizing that I'm changing the function. You see? So this is a bit dangerous, okay? Yeah. So this is a warning that this can happen, but you should avoid it again, okay? Because the scope of the function allows you to use stuff from outside inside the function, okay? A different thing that you also would do is that you can, if you try to use something from outside, but you change it inside the function. So suppose that you have this change x here, okay? What does this do, right? I have I receive some variable y, right? And then I assign x to y to x, okay? So I'm changing the value of x and printing x. What is going to, so here I had x equal 5. I'm going to say pass this to, I don't know, some value, and I'm going to change the value of x inside the function. So the x inside this function is going to change, okay? Is the x outside of the function going to change too or not? Okay, so the answer is no. Okay, let me do this with this thing here, right? So let me print x before. Yeah, this is a bit confusing, right? So yeah. So before. Yeah, like this. Before and after. Okay. Here. Before I had 5. Here I change, you see, I call this function change x, and inside the function, it changed x to y. Y was the value of 42 here. So it printed 42 inside the function, right? But it didn't change the value of x that was outside, okay? So after x is still is valid 5, okay? Right, so this is it more or less clear what is happening or not? So this is, this means changing, when you use a variable that is not an argument inside a function, you are copying the value from outside, but you are actually making a new variable inside. And if you change it, you can change it inside, but it doesn't change the value outside of the function, okay? It only changes the copy of the variable inside the function. Does it make sense? I told you that this is a bit more subtle, okay? But yeah. So my recommendation is that you just avoid, whenever it's possible, you avoid using variables from outside this function inside a function in any way other than passing arguments, okay? So it's the best is all variables from outside that you want to use inside, you use arguments for that, okay? This is the best approach, okay? So you don't get surprised with stuff like this, okay? And finally, there's this other example here where you both try to when you use the function from the variable from outside, and later on you try to change it, okay? And when you do that, it gives you an error, okay? Because this is a case where you first use it from outside and then you tried to define a new one inside, right? So this is the compiler here gets confused and gives you this kind of error, this unbound local error, right? So I think previous versions of Python allowed you to do this, and it was a bit of a mess, and now they don't even allow you to do this, okay? So using both the OP from outside and trying to create a new one, assign a new one from inside, okay? Yeah, so this is, I told you, this is a bit more complicated, okay? Well, this is already 3:30, yeah? Wow, I don't believe it. Time flies when you're having fun, right? So, yeah, it's more fun today, right? So, can we spend a few more minutes just to finish this, because I'm going to start the next one using modules and libraries, right? So, the way you import, and then you can also, this is the last section, so we can also review everything later, okay? So modules and libraries, or libraries, right? So these are pretty much the same as packages in R, okay? And these are files that, or mini files, right, that contain other functions and objects that you can reuse, right? And Python already comes with a lot of modules by itself, and you can also add more libraries, installing them into your computer, okay? Like Numpy, SciPy, Matplotlib, that are the main ones that we're going to use. They don't come with Python, okay? But you can install them on your computer. And the basic syntax is just import the module, okay? And it means that now, so for instance, you don't have a square root function inside the basic Python, okay? Or inside the already available, right? You don't have this sqrt function, right? But if you import math inside this module called math, you have an sqrt function that you can use, right? And then you use math.sqrt, right? So this sqrt, this means that the function sqrt, the square root function, is inside the math module, okay? This is why dot is a reserved character, right? You cannot use this for variable names and so on, okay? So math is square root here of 16 gives you, this gives you 4, okay? This is 4, right? Okay, now if you want to, so you know, square root is inside math, okay? Suppose that instead of importing math, I just want a few, so you see, now math is kind of a variable name, is a name, the name of the module, right? And if you want to not have the name of the module available, but just want to get some functions, some specific functions from inside the module, you can do this other way here, okay? So you do from module import, and then you have the name of the functions here. So I'm importing here two functions, seal and floor. This is round up and round down, okay? And then you have here, and now you see that when you do this, now you have seal and floor available without math dot, okay? Now you can call seal and floor directly without math dot seal math dot floor, okay? So this is a slightly different way, and when you call this, you have here 4 and 3, okay? 4 and 3, I rounded up or down, okay? And finally, something else that you can do is, suppose that you want to import all of the functions inside the math, right? Including square root, seal, floor, everything that is over there, okay? Then you have this instruction here that is from math, import asterisk. Asterisk means import all, import everything, okay? This was very common many years ago, but these days is really frowned upon, okay? It's better not to use this because, for instance, inside this stuff here you have square root, exponential, sine, cosine, and so on, right? But there are other libraries, suppose, for instance, that we're going to use also Numpy, okay? Numpy also define square root, seal, floor, sine, cosine, exponential, and then you're going through your code, and if you use two different libraries that provide the same function names, they clash, and you no longer knows what function came from what library, okay? If I import everything from math and then everything from Numpy, then the definitions from Numpy overwrite the definitions from math. So this becomes a mess, right? So it's always preferable to not import everything from the module, but instead import it in this way, okay? But then, do I have to keep writing math dot all the time? This is a bit boring, right? Math dot something, math dot something. So we have this other construction here that is import math as something else, right? And then now the name of the module is m, right? So it's a lot less to write. So it's just m dot function, okay? So this is the way we are going to prefer for using modules. We are going to import the module name and call all the functions inside with m dot number name of the function, okay? Someone had a question? Yeah? No? Okay, so this is, I think this is the end here, okay? So, I don't know why, yeah. So, we are, of course, going to talk a lot more about modules and modules that we're going to use, especially the ones I mentioned, NumPy and SciPy and so on. But this is for another time, okay? So, thank you very much, and that's it for today. I think tomorrow we are going to work a bit on a few exercises, and also I'm going to show you a little bit about NumPy just to get it started. But I think it's nice to do some exercises first, okay? Okay, so any more comments? Otherwise, yeah, so that's it. Thank you. Bye.
Hello. Now you're going to work on your project, right?